Consider the charges Q, Q and minus Q placed on the vertices of an equilateral triangle. Find the force on each of them. Okay. So the minus Q charge will be attracted towards the positive Qs in these directions. So the net force between any two pairs, the force, let's name these A, B and C. The force on A by B, this would be K, Q1, Q2 by R square. So that is L square. Or this is the force between any two pairs of charges. Between the positive pairs, it will be positive, obviously. Okay, so let's find out the force on A. Now, A is attracted by the charge placed on B and by the charge placed on C. The angle between these two forces is 60 degree and the magnitude of these two forces is this much. So this is the magnitude of the two forces. Okay. So the net force on A is the vector sum of force on A by B and force on A by C. Therefore, the magnitude of this force on A, this would be the vector sum, that is root of FAB square plus FAC square plus 2FAB FAC times cos theta. Okay. Now the magnitude of all of these is KQ square by L square. So I forgot the square here. So these three things can be taken out of the root. So therefore the net force on A is KQ square by L square. Inside the root bracket we have 1, another 1 and twice cos 60. And cos 60 is half. So even this third quantity is 1. So the net force on the charge placed at A is root 3 times K Q square by L square. This is the total force on A. Obviously, the direction of this force is downwards. This is the direction. So this force is directed towards the midpoint of the line BC. Okay. Now let's find out the net force on B. Now the charge placed at B is repelled by the charge placed at C in this direction and is attracted by the charge placed at A. The magnitude of these forces is still KQ square by L square, but the angle now is 120 degree. So this is 60 degree. So the angle between the force on B by C and the force on B by A, the angle between these forces is 120 degree. So in this vector sum, we'll have cos of 120 instead of cos 60. Rest everything will be same. So we can directly write off these. As the force on B to be K Q square by L square. The root bracket will have 1 plus twice cos 120. Cos 120 is minus half. So this is minus half. So this term becomes minus 1. So KQ square by L square, 1 plus 1 minus 1. So these two ones cancel out and the remaining force is only KQ square by L square. So the net force on B is 1 by 4 pi epsilon naught Q square by L square. And so is the net force on C. Now the net force on B is obviously in this direction. Since the magnitude of both the forces is same, the direction of the force is here. So making 60 degree with this line. Okay. Same will be for C. The net force on C due to B will be towards the right. The force on C due to A will be attractive because they are opposite charges. So it will be in this direction. The angle again would be 120. And the resultant force will be making an angle 60 degree with the line BC and with the line AC. Okay, the magnitude of this force is going to be same as that of FV. So this calculation goes for FC as well. Okay.